Hi, this is Tom, and this is lesson 22, the z-score, part 2. We're going to use a problem that we've looked at a few times before, and it's this. The average American male is 70 inches tall, with a standard deviation of 4 inches, and is considered to be normally distributed. So let's write down a little bit of information. We can say that the mean of our population is mu is 70. We could also, you might argue, at least for now, that it's also x bar. We're going to use those interchangeably, at least at this point. In this video soon we'll talk about those further. Also, we said that the standard deviation is 4, and you could also think of it as s with this little subscript of the letter n. Now, I have a normal distribution drawn below, and it says that the mean is 70. Well, the mean always goes right in the middle. And then the mean goes right in the middle. Now, this time, if we go one standard deviation above, it's not a 1, it's a 4. So 70 plus 4 goes into my next position. That's the first standard deviation above the mean. And then if I add another 4 to that, so let's write it like this, plus another 4, that's 78 inches tall. And finally, if I add even another 4 to that, I would be at 82 inches. And likewise, if I took 70 and I subtracted 4 from it, well, this would be 66 inches, one standard deviation below. If we subtract another 4, we'd be at 62, and subtract another 4 to be at 58. Now, here's how this works. Remember when we had the empirical rule, we knew that the certain amount of data would fall in between the standard deviations. So a few things that I want to do here is I want to practice with the z-score. So I'm going to erase some of these little numbers down below. And let's work with this. If this was the standard normal distribution, so these are x's, these are data values here. If I was working with the standard normal distribution, we said there's z values, and we had a 0 in the middle, a 1, a 2, and a 3. And then below that we had a -1, a -2, and a -3, like that. So what I want to do is a couple things. First is show you how the z-score works. So we have a formula. It says the z-score for some number x is equal to the data minus the mean of the data divided by the standard deviation. Standard deviation, Sn. So for example, if I wanted to find, so let's do this, find z-score for, let's try 74. So what we would write is this. We'd say the z-score of, or the z-score for 74, that's how we use our notation, is equal to, and notice that the z parentheses 74 parentheses, it doesn't mean multiply or divide or add, it's just a note-taking system to say that you're finding the z-score for 74. So I take my x value, that's 74, I subtract the mean, well that's 70, and we divide it by the standard deviation of 4. The order of operations tells us to clean up the numerator and denominator. So the numerator is 74 minus 70, well that's 4, and the denominator is already cleaned up, and there it is. Notice that these match, so there's the 1, and it coincides with the 74. And so you could continue doing this. And let's try one more. Let's find the z-score. Let's try one below, like 62. So that would say you take 62, you subtract the mean of 70, and you divide by 4. Now, if you take 62 and you subtract 70, that's -8, or -8. Divide it by 4, and you get -2. And if you notice up here on our picture, that's the same thing that we have on our picture. So now let's try a problem. So I'm going to use my picture again. So let's make a copy of it. We're going to bring it down here. Copy that and put it right here. That looks pretty good. So I'm going to take that, erase that, and all these little dots, I don't need those. Put our minus sign back, and I think we're ready. So what I'd like to do is find the percentile rank of 72. So find the percentile rank of 72. Now, here's where it gets interesting. So let's do this in another color. I like the orange because we can see if you just eyeball it right here, 72 fits nicely right in between 70 and 74. But if we drew a little picture here, and I'm going to continue with my picture, notice that the area to the right, this little area here, this green area, the light green area, notice that that is smaller than this dark green area to the left. So it doesn't that little line, the little orange line, even though it divides between 70 and 74, it doesn't evenly divide the area. So because of that, what we need to do is we need to find the z-score for 72. Then we can use the tables like we did in our previous video. So let's take a look. So here's 72, and what I want is the percentile rank, so I need to know everything below 72. Now, before I can use my tables, I have to first convert 72 to a z-score. So let's see, that's z-score for 72. That's going to equal, sorry, that little 2 is kind of hard to see. Let's make that a good looking 2. So I would take 72, subtract 70, and then divide by 4. So 72 minus 70, that's 2, divided by 4, so that's going to be a half, or 0.5. Now we're going to scroll way up above, and we're going to find 0.5 on our table and see what kind of an area that represents. Scroll up here, use our highlighter. So here's 0.5 right there. Oh, and 0.50, that's right there. So it looks like 6915. So let's come back down here, and we can say that this pink area here is 0.6915. So what we say is the percentage of data, so we use an X, the percentage of data less than 72 is equal to 0.6915, or you could say 69.15% of the data. So a score of 72 is in the 69.15 percentile. And likewise, if you wanted the percentile, the percentage above, so then percentage above 72, if I could spell that right, I would. One more backspace. Percentage above 72 is, remember, if I kept shading the whole picture, I would shade 1. So let's think about that for a minute. Let's do yellow here. If I shade the entire picture, all of this, that's 1. And then if I subtract where the pink and the yellow overlap, Well, then what I'd be left with is this light blue region right here. And that is how we would find the percentage above 72. So we'll leave the blue. So a percentage above 72 is found from taking the whole, subtracting, so 1, and we're going to subtract the 0.6915. So if we do that, that's going to be 0.3. Shouldn't do this in my head. I'll probably make a mistake here. So I'm going to grab a calculator. I have one handy. So 1 minus 0.6915. So this is 0.3085, or you could say that 30.85% is above. I hope that helps. And in the next video, we're going to change the process and see what score corresponds to a certain percentile. Thanks for watching.